When should we use a large language model? When does it make sense to maybe use a smaller model as an alternative to a large language model? That's what I want to explore here. Let's start by looking at some of the research that's been done on the performance of large language models. So here's a recent paper looking at sentiment with ChatGPT. Sentiment's a great example of text classification, and I see lots and lots of people using these large language models for text classification because they do such a good job. When this paper started to look at sentiment, the initial results it's found was that ChatGPT didn't do as well as state-of-the-art models. But then they decided to dig deeper and look at the results of what ChatGPT was giving. And once they analyzed the results, they found that ChatGPT was actually doing a very good job, a much better job at understanding sentiment. And for the authors of this paper, they felt like ChatGPT was really a universal sentiment analyzer, much better than the existing state-of-the-arts. And that probably lines up with a lot of our intuition that have used these models. Same thing when we go over to summarization, where there's been papers written that compare humans that doing summarization versus GPT-3, and it looks like it's a dead heat, and I feel the same way when I see summarization results like that. These models are really close like that. Now, here's one on reading comprehension, and it brings up another aspect of large language models that I want to highlight. One important thing to think about is the size of the large language model. The larger the language model it is, the more world knowledge it's going to have, the more fluency of language, generally speaking, it's going to have. And you can see that here when we're looking at the reading comprehension scores. They get better as we get to a larger and larger model. Of course, a larger model has some other trade-offs like inference time, but we'll put that aside. Now we'll see that the fine-tuned model here, when we're working with smaller language models, a fine-tuned model does much better. But once we get to the largest and the best of the large language models, again, you'll see that they can start, when we're using approaches like few-shot learning, beat out those state-of-the-art. Where Stitch Fix had a problem where they needed product descriptions written for all their products. They have lots and lots of products. They currently have humans doing it, but they decided, hey, let's try fine-tuning these large language models. And just as a reminder, the way fine-tuning works is we give the language model lots of examples. In this case, they gave it a few hundred examples of how their people had written. What I'm showing on the screen is a little bit different. It's just to show you the idea that we're going to actually provide data and change the model weights as part of the fine-tuning. But when they did this, they were able to get the OpenAI model to write much better. The new descriptions the models wrote were actually rated higher than human-written examples. So again, just showing you what these large language models can do. And this is where I see commentators like folks like Armin, who was on a Cohere podcast, talking about how NLP used to have lots of different domains prior, different models and different approaches within them. But for him, his perspective, it's all dead. These large language models are really ruling across all these niches. So does that mean we should just take large language models and that's the end of the day? Let me give you some examples that maybe why we just don't always want to use large language models. Take somebody like Roblox that has to do real-time text classification, and they have to do it across billions of daily requests. Imagine having to pay that bill to OpenAI for doing billions of daily requests. You can see why they'd want to look for an alternative to using a large language model for some of their tasks. Another example was a recent blog post by Honeycomb that talked about some of the difficulties they had when they started to put together using large language models to build a query assistance. The idea of this query assistance was to be able to go from, let's say, like something like text to a SQL type of language. And what they found is when they were building this out, they had to actually chain together lots of different prompts. And that chaining often led to a reduction in accuracy. But the other thing it often did was it was slow. If you can think about each query takes 2 seconds, 5 seconds, and now you have 5 of them, response can be really slow. And so this is some of the reasons why we might want to think about alternatives to using a large language. Now, NLP has long been dominated by kind of smaller models. If you go out and look at the Hugging Face hub, there's lots of pre-trained models for a variety of NLP tasks that you can just grab off the shelf. Now, some of these are already there for things like financial sentiment. And what we find is when we use a model that was trained on a specific domain, it does better than these general purpose models that were kind of more consumer led. And if you think about it, words like market mean something very different to a finance person, or the word bond. And models that recognize that and understand that specialty domain, they're going to do better. And we can see it here where the FinBERT model does better than GPT-3. I quickly looked and I found another example very quickly in healthcare. Same kind of thing where we're doing entity recognition, where we want to find, what part of the text is about the medical problem, what part is about the treatment. Well, the BioBERT model does much better than the general purpose GPT-3 model like that. So now hopefully you're starting to kind of think about and see the trade-offs between these models like that. I like to think of it, just generally speaking, as you can have something like an iPhone that has lots of different apps. One of the apps might be a camera versus a device that's just a camera, that's specialized, right? And there's times when you want to use a generalist. I just always want my phone with me to be able to take a quick snapshot. But on the other hand, if it's something I really care about, if it's my kid's wedding, I don't want the photographer showing up with an iPhone to take the pictures, right? I expect him to have specialist gear because I'm expecting that bit of quality that you'll get with that. And you can think about the same thing when you're comparing the trade-offs of using a large language model versus using a specialist. Like that accuracy and speed is going to favor that smaller, kind of more specialized NLP model. The cost might vary. You can see, either way by token, having the overall model for the billions of calls. Agility varies. Prompting can be very quick, especially for people that aren't data scientists to do. But then you also have things like explainability, ML ops that might focus you towards kind of smaller models, existing open source models as well. So hopefully you're starting to see kind of how we can start thinking about either of these ways like that. I'm a big believer that we're going to have both of these. It's not a one or another thing. Large language models are great for proof of concepts, for testing out things. But then as you start developing, as you start figuring out the smaller tasks you want, maybe you'll substitute in some NLP models for that text classification part instead of using the LLM. LLMs are also great at generating the data. I see a lot of times nowadays when we're using these smaller models, the data that comes to train these models actually comes from the large language models. So I think we can all get together and work together. So hopefully now you have a good sense of when to use large language models, when to use a specialist, and how we can kind of make it all work together as well.